Okay, here's our third and final example for our constant acceleration problems. We have a girl on roller skates is traveling at 5 meters per second when she sees a cat in her way. She slows down to a speed of 2 meters per second in order to let the cat pass by without running into it. It takes her 2 seconds to slow down to this final speed. A, what is her acceleration? And B, how much ground does she cover as she is slowing down? So let's read through again and highlight our givens. We have a girl on roller skates is traveling at 5 meters per second when she sees a cat. She slows down to a speed of 2 meters per second to let the cat pass by, and it takes her 2 seconds to do this. For A, we want to find the acceleration, and then B, it says how much ground does she cover? So first and foremost, let's write down our actual givens here. She's first traveling at 5 meters per second, so that means it's the initial velocity is 5 meters per second. And then she slows down to 2 meters per second. So that will be our final velocity, 2 meters per second. And then it takes her 2 seconds to do this. So time is equal to 2 seconds. Now for part A, we want to know the acceleration. So I put A equals question mark. Now, before we pick an equation, I want you to think about this and think about the sign of acceleration here. Remember, acceleration and velocity, right? When they're pointed in the same direction or they have the same sign, so say they're both positive or they're both negative, that means that the object is going to be speeding up. If they're pointed in opposite directions, so say the velocity is positive and the acceleration is negative, or if the velocity is negative and the acceleration is positive, that means the object is going to be slowing down. So since she is going to be slowing down for this cat, and we're saying that she's traveling at a positive 5 meters per second, what do you think the sign of acceleration is going to be here? The answer that we get, I mean. If you're thinking negative, you're correct. So we are going to get a negative number, or we should get a negative number for the acceleration here. So we have initial velocity, we have final velocity, we have time, and we want to find acceleration. So we use that first equation. It's called the first basic equation. Final velocity equals initial velocity plus acceleration times time. Here, I'm going to rearrange this equation to solve for acceleration, and that's actually just the definition of acceleration. Acceleration equals v final minus v initial divided by time. And then plugging in our numbers, we get acceleration equals final velocity, which is 2 meters per second, minus initial velocity, which is 5 meters per second, divided by time, which is 2 seconds. And so 2 minus 5, that ends up being a negative 3, and then we're dividing by 2. So we get a negative 1.5 meters per second squared for our acceleration. And we were correct. It is a negative number because we are slowing down. Now notice that I still call this an acceleration. In common English language, we say, oh, it's a deceleration, but I don't like saying that in physics because technically it's still an acceleration. It's a change in velocity. I don't use that term deceleration even for slowing down in physics. And then finally, for part B, it says, how much ground does she cover? Now, what does that mean, how much ground? What do you think? If you said that it means your displacement, you're correct. So here we're solving for delta x, or displacement. Now we have every single other variable here, so we really can use any equation to solve for displacement. I'm going to use that second basic equation again, just because it's already solved for this displacement. So we get delta x is equal to v initial times time plus 1/2 acceleration times time squared. Delta x here, our displacement, will be equal to initial velocity, which was 5 meters per second, times time, which was 2 seconds, plus 1/2 times the acceleration, negative 1.5 meters per second squared, times time, 2 seconds, squared. So we can plug this into our calculator. We get 5 times 2, that is 10, plus 1/2, 0.5 times, don't forget that negative, a negative 1.5 times 2 times 2, and I get negative 3 for this. So I end up getting that my displacement, delta x, is 10 minus 3, which is 7 meters. And that's our answer.